Hello, or hello again, depending where you are. If you already learned AAS, then you're learning the last shortcut. If you didn't watch the video on AAS, then you are learning HL shortcut, which is 4 out of 5. So total, we're going to have 5 shortcuts. First thing we need to do for this shortcut is understand this shortcut only pertains to right triangles. So the first thing we have to do is review the parts of a right triangle if you don't remember. So the first thing is there's 2 parts here and here that don't have that make up the right angle right here. So the 2 parts that make up the 90 degrees, which means this and this are perpendicular, is called the leg and the leg. Okay? These legs could be the same, or they could be considered a short leg or a long leg, doesn't matter, but they could also be isosceles. But what is most important is there's a piece that lies across from the 90 degrees. And due to anything we know so far about triangles, if this is the largest angle, that's going to be the largest side of the right triangle, and that's what we call a hypotenuse. And so you probably remember this from middle school. But you need to know those parts, and there's a reason, because our shortcut only deals with right triangles. So let's look at the name of the shortcut. The shortcut that we're going to learn today is called the hypotenuse leg shortcut. The hypotenuse leg shortcut is short for hypotenuse and leg. If the hypotenuse and a leg of one triangle are congruent to the hypotenuse and leg of another triangle, then the triangles will be congruent. So if you look down here, what you have to remember, it's only a right triangle. Right triangle. It's not any triangle, it's only a right. So if I come here and I look here and I say A and C is congruent to DF, and I say that FDE is congruent to AB, then that's a leg, congruent to a leg, and a hypotenuse to a hypotenuse, and it's a right triangle. Then I can write my congruence statement that says ABC congruent to DEF. The reason that we call this hypotenuse leg instead of, if we looked at this, it would be angle, side, side. And again, we're not going to use that word. So I basically say it's okay to get ASS as long as it's in the right triangle. Okay? So we need to keep that in mind. Never are we going to write ASS, but we might have to write HL. So let's look at our first example. Okay, one thing you need to consider when you're looking at examples is you come right here and say, oh, it's a right triangle, it must be HL. Please remember, you could have a right triangle and it doesn't have to be HL, but if it is a right triangle, you want to check for HL. If it's not a right triangle, HL is not an option. So when I come here, I say right triangle, HL is an option. Here is congruent to here, which means this is a leg, congruent to a leg, and BC is the hypotenuse, and DF is the hypotenuse. So the postulate that we would put on the blank is HL, and if I say ACB, you'll say EFD, and hopefully you're doing that on your own. Let's look at example 2. Are these congruent? So I come here, I see it's a right triangle, so I say, oh, I definitely want to consider HL as a suggestion. But when I look at this is a leg congruent to a leg, and a leg congruent to a leg. So HL is not an option because the hypotenuse is not involved. Could they still be congruent? Sure. So what are they congruent by? Side, angle, side. And I'm going to say ACB, EFD. Okay. Go ahead and take a second. See if you can figure out if it's HL, if it's not HL, if it's not congruent at all. Well, first thing I'm going to do is mark DB congruent to DB because they share it, and that's by the reflexive property. So if they are congruent, now I at least see I can also put 90 here because they're a linear pair. So if that's 90, that's 90. So I know this is a right triangle. I probably want to keep my eye out for HL. If you didn't pick up HL, you might see angle, side, side. So you say to yourself, angle, side, side. Don't want to call Miss Richards that. So I know that's not true, but since it's a right triangle, you write HL. And if I put ADB, A is the same as C, and then DB. So CDB would be correct. Okay. Let's look at our example. Let's see what other information we can put in. So when I come to this, I see that they are touching, which means I can probably draw on it. And the first thing I see is that there's a pair of vertical angles. So I'm going to say this guy is congruent to this guy. And I use 3 only because 2 is already used. So they're congruent. So when I look at this, I see there's an angle. It's a right angle. So I want to check for HL. But there's no side lengths whatsoever. So obviously the hypotenuse and the leg are not congruent because there's no legs. So this is angle, angle, angle. And now I'm going to tell you that we're never going to be AAA, which is a towing company. Angle, angle, angle does not prove two triangles congruent. For example, I can have, if you can just picture this, maybe a 90, 30, and 60 triangle, a right triangle. But guess what? As soon as I go like this, I can also have a 90, a 90, 30, and 60 triangle, 30 here, and 60 here. So exact same triangle with the same degrees, except obviously they're not congruent. AAA does not prove triangles congruent. Go ahead, take a second before I give you the answer. See if you think it's HL or you don't. It's definitely a right triangle. This one would be 90 degrees as well because they are a linear pair. And then I can mark this congruent to this because of the reflexive property. And now I say to myself, it has this leg congruent to this leg, and it has this hypotenuse congruent to this. So yes, this is an example of HL. All right, and I think we only have one more example, so go ahead and see. I don't even ask you basically if they're congruent, but you never want to fill out a congruent statement unless they are congruent. So we want to take a second and see why they are. And it comes up here that this is congruent to this because of the reflexive property. I have this leg of the right triangle congruent to this leg, BD congruent to AC, and I have the hypotenuse in both of them. So it is definitely HL makes these congruent, and ABD, and you'll see A is up here, it goes down to B, so I have to go from D up to C over to A. So triangle DC. Triangle DCA. Okay, so that's it for HL. Why don't you work on the worksheet? I'll be around. Hopefully you understood that, and that if you already watched AAS, you saw that. If not, you'll watch that next, and now you have all 5 properties. Remember, it can't be ASS unless it's in the right triangle.